Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, or TuneIn Radio, and you can also add our RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, with links in the show notes. Please give us feedback. You can leave a review on iTunes, send us a tweet, send us an email, or leave us a message on Google+. And I'd like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. I would also like to thank Hired, a job marketplace for developers, for sponsoring this episode of Podcast.init. Use the link hired.com/podcastinit to double your signing bonus. We are recording today on September 7th, 2015, and your hosts as usual are Tobias Macy and Chris Patty. Today we're interviewing Trent Nelson about PyParallel. Trent, could you please introduce yourself?
Yeah, hi guys. My name is Trent Nelson. I'm a software engineer by trade, a ripe 33 years old, living in New York, working for Continuum Analytics. So my role at Continuum is to, essentially I do a lot of on-site consultancy. So various clients in sort of finance and other industries will engage with Continuum for help in all kinds of fields. I very much enjoy working in Python, but we also do a lot of work in C and C++. I've had a background in Java, and the last project I did had a lot of PLSQL and Oracle work in it as well. So I generally enjoy solving interesting problems, especially on client sites where, you know, it can be tied to a specific business need. And also, I guess I'm the founder of PyParallel, which is
How did you get introduced to Python?
So that's an interesting one. The Python's such a fascinating language because it's just got this like simple, beautiful elegance about it. So I didn't actually I did computer science at university I actually did it for a year and a half. So I basically went through the roll of subjects that you could take and picked all the interesting ones and then tried to do them all in the first sort of 18 months. So I did like UNIX and C and basically all the ones that seemed really interesting and seemed like they would be the necessary foundation for a computer science education. I ended up, so this was around 2000. So the .com boom was in full effect, and I was having people sort of left, right, and center around me getting these like amazing job offers that were it basically like that happened enough where I ended up thinking, well, you know what, I kind of want an awesome job as well. So I ended up putting together a resume, and halfway through my degree, I applied for I think I just sent my resume to a recruiter and ended up getting a job offer from the first place I interviewed at. So it was an interesting company. It was a very engineering-oriented company that did essentially railway control systems. So it was a really UNIX, C++ type environment. Digital UNIX and the Alpha processor, which I was obsessed with at the time. So that's kind of how I got into that sort of Unix and C arena. A couple of years later, I ended up getting into the more financial arena, and then I actually specialized in a couple of tools that somewhat show my age, ClearCase and ClearQuest. So they were configuration management. ClearCase is basically like a chunky 90s version of Git done really slowly. It's
Sorry, I was a release engineer, so I have some experience with that.
Case. Such fond memories. And ClearQuest as well. I mean, that wasn't, yeah. So anyway, they served a very useful purpose at the time. And, a lot of companies, they're still kind of integral parts of their infrastructure. So I ended up specializing in a lot of ClearQuest stuff, and specifically within that, the sort of the release engineering configuration management teams. That was good because it allowed me to continue to write things like Java and C, but not necessarily have to be constrained by the particular domain. So, I wasn't doing like Java in like a finance environment. I could experiment with a lot of languages, and I think that was good because it gave me an appreciation for all the different types of ways there are to solve a particular problem. And especially in that role, the main thing that we did on a day-to-day basis was work with other teams within other development teams. So you would have teams, that were Java-based at the time. You would have teams that were C-based. There'd be entire projects in PLSQL. There'd be data warehousing stuff. So it was a really good mix of, all kinds of industries. So that language-wise, I actually ended up specializing quite a lot in Perl, of all things. So this is, this is epic sort of early 2000s stuff. I remember reading an article by Eric S. Raymond about Python. So I think this was probably like circa 2003 or 2004. And to this day, I still think the article is really well written and gives this very nice introduction to Python as a language and shows its appeal for those that hadn't otherwise heard of it. So I think I just sort of started learning it in my own time. And then essentially a couple of years later, I had an opportunity to do a project where we had to do a lot of really peculiar database migrations from, again, a lot of disparate bug tracking systems. So I think there was 10 or 20 different configuration management systems that we had to interface to and then put them into a new ClearQuest system that I was designing. So I did a review with some of these teams, and it became very apparent that a very dynamic, flexible language was going to be much easier to do this in than something more heavyweight, so like a Java JDBC thing at the time. So I ended up, I didn't actually know Python. I just was kind of convinced at the merits of the language prior to starting it. So that was interesting because that gave me my first sort of, so we actually hired someone on this particular project to take care of that. So once his contract ended, I ended up picking up from his stuff and spending a bit more time sort of rewriting it and learning it and that sort of thing. I got a lot more opportunities as the years went on. So 2006, 2007, I was doing a lot of Java and C++ on the side, but I was always looking for projects where I could essentially use Python because it was just such a fun language to program in. And I did one particular project where it was a database migration. So there was these two identical databases that I'd actually designed a couple of years before, and they decided that they actually wanted to have it in a single global database. So the problem that it was a vendor's database. So when these two databases started out, they both started out from the same sequence IDs. They both started out with essentially the same schema metadata. So to merge them into one, you were going to get all sorts of duplicate keys. And there just wasn't really any way to merge them cleanly with the vendor API tools. So I ended up using Python to come up with a way to essentially interrogate the API that ClearQuest provided to build up a model of the database. And then essentially I used Python to generate raw SQL statements that I'd sort of like hand-tuned to efficiently do this migration and deal with some of the issues with duplicate IDs and that sort of thing. So that was around 2007, 2008, and I really loved the project that much. I really loved working with Python that much, where I ended up getting involved in the Python community. It was a lucrative contract, and I wanted to kind of give back to the community. So I ended up basically offering my services for the Buildbots, especially the Windows Buildbots, and attempting to help get Python ported to the 64-bit versions of Windows that were coming out. So I think that was around 2008. I ended up going to the Python conference, and it was fantastic. It was my first PyCon ever. It was in Chicago. I ended up meeting Guido and Martin and I remember meeting Mark Hammond as well. I don't think he's made an appearance since then. But all these people that I'd seen and interacted with on the mailing lists, and was able to then sit and sprint on the thing I liked most was the sprints after the PyCon, where you could actually sit down with the core developers and just start hacking on stuff and just trying to fix things. So I ended up getting committer privileges during that PyCon. That was great because that great way to continue my involvement in the project. I was really, for whatever reason, I was really interested in the Buildbots. Especially I see the same pattern in a lot of new committers now. So the Buildbot infrastructure that Python has, basically, for any time that we make a commit to Python, there's these like donated machines that will be notified and then essentially build from scratch and provide the committer for a way to say, okay, look, this program worked on my machine, but I broke it on Windows. So I mean, it's not great, but it was definitely better than nothing. It was really the best thing that we had for ensuring a reasonable level of sanity at the release level, and also just on an individual commit level. I ended up. so there were issues. Like once, if it was failing, so there was someone that had this alpha system running True64 Unix at the time, which I had such a fascination with that stuff, and I spent a lot of time doing that stuff back in the past. And I think someone had an Itanium system, and it kind of got the gears turning in my brain. I'm like, wouldn't it be great if we had access to these systems, and we could actually, rather than just getting like a compiler, we could actually like log in and have access and have your own compiled environment and try fix it directly. So that led to Snakebite, which ended up consuming. It wasn't a particularly well planned out project from my perspective, and I think looking back on it, I mean, it still exists, it's still a thing. I just it's because it was so infrastructure based. I basically ended up building a server room at Michigan State University, so I filled 3 42U racks with an array of different sorts of hardware. So basically, I wanted to have coverage of every sort of mainstream Unix at the very least that there was. So there was an SGI IRIX box. There was an Alpha server back from the day with True64 Unix on it. There was a huge Itanium system, like a quad Itanium system that HP donated, and that was running HP UX. I bought a whole bunch of PowerPC machines that were running AIX. Solaris machines, Sparks, and AMD 64 stuff. It was a lot of Unix. It was, I was kind of partly reliving a lot of the sort of the childhood fascination that I had with Unix as an operating system. The problem was that that's an infrastructure project. I didn't have any governance set up to help continue providing funding for that, and it also became very apparent that I much prefer building things than I do doing project governance. So for every opportunity where, I to set up a community and to ensure that, people can continue to maintain it and stuff, that always took second place to configuring a new system or, that sort of thing. So Snakebite's a work in progress. Funnily enough, the FreeBSD server, and this is a perfect example of not having any governance. The FreeBSD server that I've got is currently down. I think it's just not responding to anything, so I can't actually get into Snakebite, nor is the website up. So that's it's something that I need to give a bit of TLC to. But Snakebite went on. So the one thing that it was able to do towards the end was actually have all of these platforms where, we could have a Buildbot running on, AIX and True64 and IRIX, and a lot of these platforms aren't particularly relevant anymore. But there was, I built some infrastructure where we synced to the Python committers SSH keys, so that once they were granted commit access to hgpython.org, they were able to SSH into this Snakebite system that I set up and essentially have access to any one of these machines, and all the sort of logins were synced and stuff. It was really fun because it was the type of thing that. So this was obviously around the time that Amazon was spinning up their stuff, but that's all sort of Linux x86 stuff. None of the problems that Python was having was on Linux, because that's tends to be the major development platform used by all developers. So essentially Snakebite was a very fun experiment. It was around 2012 though that I essentially came up with the idea for PyParallel, which is obviously the topic for this podcast. So I will. That was my long-winded explanation of how I got into Python, and sets the scene for some of the stuff that I'm sure we're going to talk about later.
Back when Unix meant workstations and hardware hadn't been commoditized, right?
Yes, yeah. I'm just so fascinated by it all. And it really was. I can kind of understand the appreciation that people have now for. Once you get into your 50s and 60s and restoring old muscle cars, and it's what they're actually restoring is the car that they fantasized over when they were a teenager, and those formative years where you do have the amount of passion that you have for something isn't particularly connected to any form of rational thought. So but that's something that stays with you. That's that you build upon that as the years goes on. So yeah, I guess my muscle car was my interest in the Unix operating system.
So for our listeners who may not be aware, can you give us an overview of what PyParallel is and what makes it different from other Python implementations?
Right. So Python's biggest issue to date, or potentially maybe a better way of phrasing this, Python's most complained about problem is the GIL, the global interpreter lock, that prevents Python from optimally using multiple cores on, the contemporary hardware. So essentially, PyParallel is a project that I came up with that took a step back and looked and basically said, what can we do how can we change Python so that it can exploit contemporary hardware? And it's not just multiple cores, but it's also, the type of new memory architectures that are coming out and the memory latencies. How do you also exploit the new network, 10 gigabit Ethernet and 40 gigabit Ethernet and 100 gigabit Ethernet and Thunderbolt and USB 3 and those sorts of things. The device speeds that they're coming up with, they're increasing just as the core count and frequency counts are. So I really wanted to take a step back and look at, let's look at how Python has these constraints and what can we do to address them. So it was essentially the project is a way of still staying within the confines of the Python ecosystem, but also being able to leverage, multiple cores, these fast Ethernet cards, and that sort of thing.
And how did PyParallel come about? What was the inspiration that got you thinking along those lines?
As much as I'd like to say, PyParallel is this thing that I sat down and planned really well, and it was, it's always nice in hindsight to be like, it's designed for the fast multiple cores and that sort of thing. How it actually came about was me working at Snakebite, going, man, I need to get a job. I've been doing this for 3 years. I'm running out of my savings. What am I doing with my life? So I'm like, you know what? So I was at Michigan State at the time. I was like, well, I had some friends in Chicago, and I also had some friends in New York, and I was kind of contemplating, which do I want to move to Chicago or do I want to move to New York? And I came up with the idea that I wanted to move to New York, and I kind of wanted to get into things like high-frequency trading, where it's essentially the sort of the equivalent of the gaming world, where you're getting the ultimate performance out of underlying graphics cards and that sort of thing. HFT is a very raw, low level way of, the fastest algorithm and the fastest code wins. So if you can shave off microseconds or nanoseconds, it actually provides immediate financial gain. It provides market liquidity. I won't get into the comments on, the value of it as a general participant in society, but it's a very interesting technical problem. So I'd made up my mind that I wanted to relocate to New York and get into high frequency trading. The only problem with that is I had no background in that. So I had a couple of months left, especially with my research visa, and I thought, what's a project that I can put up my portfolio where I sort of envisioned this situation where I'd be sitting down with a recruiter, and they'd be like, well, why would we put you in HFT? You don't have any experience in it. So what I was envisioning was having a project where I could say, well, look, I didn't know anything about this problem, and this is what I got done in 3 or 4 months. So at that time, there was an email that was sent to the Python Ideas mailing list that was called Async Core Batteries Not Included. And that started off, it was a very innocuous email. It started off this huge email thread that ended up being the catalyst for both PyParallel, as we know it today, and also what turned out to be Async IO. So the thread basically dealt with, how are we going to address the need to deal with this, this new sort of concurrent style asynchronous IO, which is essentially, in this context, asynchronous IO basically meant sort of, non-blocking network socket IO. So how, what sort of mechanisms could we have in place to, have something like Twisted, which has been really good at setting the standard for doing that sort of completion-oriented, protocol-oriented asynchronous IO single-threaded event loop. That sort of paradigm was, that's really, I think Twisted did that really well. So the idea behind this whole thread was to, what could the standard library potentially do? For whatever reason, I decided to pick that as my pet project. And so I'd done a lot of work with Windows recently. I had been reviewing the new APIs that they introduced on Windows Vista with the thread pools and their, how it linked into all of the IO infrastructure, essentially. So I actually had this idea that, hey, look, the asynchronous IO and the solving of the GIL, we could probably kill 2 birds with 1 stone here. It was ridiculously ambitious. That's a crazy thing to try and solve at one time. So there were a lot of discussions on the mailing list, and if you go back through them, I pitched a couple of ideas. I didn't I kind of kept the crazy under under a certain level. So I didn't actually pitch the idea of solving the guild problem as well, but I did pitch some ideas that were essentially geared towards, okay, look, how can we leverage each operating system's facilities in the most optimal manner? So at that time, I felt that Windows actually had a better base to build some of these async IO primitives of. So it was interesting. So I basically decided that was going to be the project. Guido, it was funny. Guido emailed me directly. We had a chat sort of offline, and I think he emailed me the weekend that I decided to sit down and write an async PEP, which was, I guess, my version of, everything that I had in mind. So it's actually out there. We can put the link in the footnotes, but I came up with this crazy PEP that kind of merged the notion of asynchronous IO and parallel computation. Hadn't really done much CPython stuff recently, so I was I was making a lot of claims that it would be very hard to back up without any proof. And Guido's reaction was like this. So I he sent me an email asking about, did I have any thoughts about on the IOCP stuff? The timing was perfect. So I sent him that PEP as a response. Bless him. He was like, oh my, he's like, I don't know if you've like stopped taking medication or you've like started taking new medication, but like, this is just like, it's crazy. Like this is not achievable within a reasonable time frame. And he was completely right there. It was a really wacky, set of ideas. So, the other side effect of that is that there's nothing like having Guido say that he doesn't think that you can do it as a motivator to try and figure out a way to do it. I think if he'd been like, yeah, this sounds great, you probably can do that, I probably would have been like, yeah, I probably can, and nothing would have ever happened. So it's definitely the provide someone with a challenge and set the scene for to get that sort of a project. So it was interesting. Like once I had the motivation and I decided to figure out a way to like, okay, how can I get Python to optimally use all of my cores and how can I get it to so essentially solve what this guild problem was. So I essentially, just I think I spent about a week tracing through the core Python code, just trying to figure out how I would go about it. So I had some wacky ideas about like inserting opcodes and coming up with like new language semantics, and none of them appeared to be particularly. I kind of had to set the scene to get some ideas. So
the next question was, what are some of the biggest technical hurdles you've been faced with? And it seems like you're sort of leading into that. So just carry on.
So the approach that I used to address the problem was basically to start from literally, I just like fired up Visual Studio, set a breakpoint at the first point that I could find within Python, and then attached the debugger and literally walked through, like just, had it run simple parts of code, had it just to figure out, okay, what were these, how it was currently working, and just to try and set the scene for giving me some ideas for at what point could I interject this sort of new functionality that I had in mind. So I kind of had the way that I had in mind to leverage the Windows thread pool facilities. That was quite clear. What wasn't clear was the mechanism of so basically what these Windows facilities, they basically provide a way to provide a C function and some per user callback context. And you can say, so for example, try submit thread pool work. You can call that with a C function and some context, and it will actually manage this thread pool behind the scenes, and it figures out how many threads it needs to create. It can tell if it hasn't posted enough threads, it'll create some more. It'll kill threads when they're not needed anymore. So it manages all of these complexities with literally just getting into the context where, okay, I'm now still within the Python process, but I'm a separate thread. So I basically started with that and used that facility to, okay, what happened when that happened? Where did it crash? So that really set the scene for figuring out the approach that I came up with essentially being able to quickly detect whether or not we're in one of these parallel contexts or parallel threads. So I came up with at the same time, I'd kind of been reading Intel assembly language manuals, and I was kind of hoping that there'd be this like magic instruction that I could come across that would do exactly what I wanted. And it turns out there actually was. There was the way that it works is at any time I can tell what the thread ID of my current thread is, and I can compare it to my main thread ID. But I can actually make that a really, really simple like comparison between two 32-bit integers by using the CPU section registers. So there's an instruction called read fs base that essentially I use that and with a particular offset to get the thread ID. So the actual mechanisms for PyParallel were just to find out, basically to intercept all of the thread-sensitive parts of the interpreter and put in this test to say, okay, if we're a parallel thread, let's divert to a thread-safe alternative. So that really was the key breakthrough that came sort of a couple of days. So I got a prototype working in, I think the first commit that I made was around December 21st, and there was a 4-day period where I made a couple of commits. All of these were on my HG. Well, I've actually backported them, but initially it was all done against a sandbox repository on the hdpython.org Mercurial repository. But that like once I'd gotten that working, it was a very I think I had an implementation of map. So there were like 4 attempts, and on like the 4th attempt on the 4th day, I essentially got it working well enough where it could basically like proof of concept. So like, okay, there is some merit to this idea of intercepting these thread sensitive things, and it didn't appear to incur much overhead. So that was 3 months passed, and I ended up working on it as much as I could. There was a good couple of weeks there where it was a good sort of like 12 hours a day type of thing, just trying to figure out how to get everything in place. I was essentially working towards presenting this at the PyCon 2013 conference in Santa Clara in California, Silicon Valley, Santa Cruz, one of the Santas. I did. I presented like a little sort of 25-page presentation to the Python committers. So at every PyCon, there's a day at the start, typically on the Wednesday, where all the Python committers that can attend PyCon get into a room and just discuss like language things. And it's great because it's the only time each year where that really happens. So that was, it was a good scene to present the work. So again, my intent for all of this stuff was still the idea of moving to New York. So Guido, it was really funny. I get this email from Guido, and it doesn't have a body in it, but the subject is "You guys should talk," and it's addressed to this guy called Peter Wang. I had no idea who that was, and myself. And there's literally nothing else. There's like no body in the email. It's just like the subject line was like "You guys should talk." So I replied, and I'm like, hey Guido, I'm like, Peter, have you got any idea what the context is here? And it was about the parallel work. So Peter had was chatting to Guido earlier about some of the parallel ideas that Continuum were exploring. So I ended up presenting the same presentation to Peter and a couple of Continuum people, and then ended up, I think Peter and I were just chatting for like 4 hours about just everything and anything. For anyone that's ever met Peter Wang, there's no shortage of things to talk about with him. He's a very entertaining guy. It was interesting. I ended up meeting Travis as well. So Travis Oliphant, who is the creator of NumPy and the CEO of Continuum. So it was really strange. So we had this, great chat, and I was chatting about, PyParallel and their kind of work. As we were leaving, I kind of made this sort of cursory comment that, I was available for some freelance consultancy. So they were like, oh, that's interesting. They're like, how do you feel about New York? I was like, oh, that's actually like where I'm planning on moving. That's why I did all this stuff. And he's like, oh, how do you feel about, like the finance arena? I'm like, that's exactly what I wanted to get into. So it was really weird that the plan to like, let's do PyParallel, not because I wanted to like solve the Python parallel problem, but because I wanted to like relocate to New York. I don't know, like thinking back on it, it's always a really weird way, and just kind of quirky that it just sort of happened like that. So I ended up, we ended up making that happen. I ended up getting hired by Continuum. That was a long process just because I had to switch visas and go back to Australia, and there's just a lot of time involved when you're like relocating and that sort of thing. So I was able to, I think I started work for Continuum around August 1st, 2013. And I went straight onto a client side and did, it was a really interesting project. It was probably for about 18 months working on all kinds of it. It was the first project where I interacted with data scientists. So it was a sort of a financially oriented project that had a lot of a pretty large data science component to it. So it was one of the key things that we're doing, not to give too much information about, but it was to do essentially like entity and location, disambiguation and resolution. So given some unstructured text within a raw text field, to be able to discern, okay, what is this text field referring? So, it might be a address or a customer's name or something like that. So, who is this talking about and where is it talking about? And the idea is taking this unstructured text and figuring out a way to go from what was referring to potentially like the record of the custom that's being referred to, or the lat long of the location that's being referred to. So that was interesting because it opened my eyes to NumPy of one thing. So I hadn't done really any sort of like scientific oriented computing or any math oriented stuff, or even really used NumPy. I didn't really know what NumPy was and what it was used for. So it was a great eye-opening experience to see through the eyes of the data scientists. And that's, going to be, that's actually one of the areas where Python is flourishing now, just because the simplicity of the language makes it so attractive for getting out of the way and actually letting you focus on your problem at hand. So for data scientists, their problem isn't, writing software that for the sake of writing software. They're essentially trying to solve problems that, are important to the business or important to, whatever they happen to be working on. So that was great because it also gave me an opportunity to. There was quite a large Oracle component on the project, and I ended up writing a lot of PLSQL, and we had these really beefy servers that were sort of like 128 core and 512 gig of RAM, and like really ridiculous disk arrays attached to them and that sort of a thing. So it's a lot of the time that I spent essentially like exploiting the underlying hardware, like figuring out ways to get Oracle to exploit the underlying hardware. That was great because it gave me, so Oracle's got some really, really robust and mature parallel options for essentially, taking, this is my, terabyte data set, how can you chunk it and essentially do parallel computation against it, which is, obviously within the same sort of similar domain as PyParallel, just in terms of the problems that they're trying to solve. So that was great because I didn't do much work on PyParallel, mainly because I was engaged on this side. But it was great it was a very good breeding ground for ideas and just to see some more exposure about how PyParallel could potentially succeed and how it could be used in these environments. So I did a couple of presentations. So that was there's like a 153 page presentation that I did at a conference so it was a PyData Conference. So Continuum holds a PyData Conference in New York it's around November-ish. So I had this Sunday slot that I started preparing a deck on the Friday. And I had this deck already prepared that I'd given at Bank of America a couple of weeks earlier that was 80 slides. And I was like, all right. So I started with the aim to cull the deck down to about 50 slides. So I think by the end of Friday, I'd had like 102. And by the end of Saturday, I'd gone up to like 130. And then by Sunday, it was like 153. So the takeaway from that is that I'm very bad at culling decks. What was interesting was that was sort of the first real public sort of projection of PyParallel and the first sort of communication about how it all sort of tied together, the asynchronous IO parts and that sort of thing. Since then, I was still working on client stuff. The next sprint that occurred on it was around PyData Gotham, which was around in 2014. What are we in now? 2014? No, 2015. Yeah, so it was summer last year where I put another sprint into. One thing I found was that PyParallel was. I had some of these like parallel primitives in place, but it wasn't doing very well for like a web server when you loaded it in under like stress testing situations. So I spent some time, addressing that and got it to a point where it actually could, run for the duration of the benchmark and actually do really well, and then subsequently crash. But it was progress. So that was summer last year, and then I really got back into it towards the end of this year. Sorry, the end of last year. So over the Christmas break, I spent about 2 weeks just in the depths of PyParallel, trying to bring all of these sort of like parallel socket IO primitives back into play. I ended up, the contract that I was working on finished in February, and much thanks to Continuum, I was able to work on PyParallel pretty much until now. So I'm going back on client sites soon, but I was able to make a lot of progress on the performance, and I was able to set up a website and that sort of thing. So that's essentially the long-winded story for how PyParallel came about.
So what are some of the biggest technical hurdles that you've been faced with during your work on PyParallel?
Yeah, so the biggest one was definitely figuring out how to address that issue with, once we're in these parallel contexts, how do we address dealing with parallel objects and memory allocation and that sort of thing. So it turns out that was actually quite easy to address once we had this mechanism in place to detect if we were a parallel thread. So this particular macro that I came up with that could easily divert to other things. The identifying whether or not something was a parallel object was the next hurdle, which we provided a way to come up with. The next big thing was probably the tying together all of these things that I had in play with the TCPIP, like client server socket paradigm. So that definitely consumed the majority of my attention this year. And it's still a work in progress, but from most of these technical problems, they're a problem until you keep looking at them and eventually come up with a way to solve them. So there's always going to be some challenges in the way, but the key part of figuring out that we don't actually need to do like reference counting and garbage collection in these parallel contexts, and we can just rely on the object semantics to control the lifetime of objects. That was kind of a key breakthrough that really set the scene for it being able to gain some traction and be a useful thing, and for something that you can actually write useful programs in.
And so you mentioned earlier how you were digging through the assembly code and the CPU instructions for the Intel x86 architecture. I'm wondering if that means that the particular implementation of PyParallel is currently tied to both Windows and a particular CPU architecture.
So it is. It's definitely still tied to the AMD 64 architecture. So there is a possibility to use it. So basically the thing that I exploit is the ability to quickly get access to the current thread ID in as little time as possible. So there is a much more portable way to do that. But I just exploited the mechanism for being able to get this per thread unique identifier from these segment registers. So ARM has a similar instruction that achieves essentially the same thing. So the operating system will actually need to have a way to do this to efficiently be able to, when it services an interrupt, to be able to switch into to figure out, when it's processing this thing that happened, like where does that user's thread or that process block contain the information. So it tends to be something that comes with these modern CPUs. So the architectural thing, it would be possible to port it to ARM in the future.
And what would be required for enabling PyParallel to run on Linux or BSD style operating systems?
Yeah, so that's an interesting one. The work that I did basically falls into two parts. One was the changes to the interpreter to allow running of essentially simultaneous threads without causing mayhem and also without the need to continually lock objects and unlock objects and that sort of thing. So those changes are essentially platform agnostic. So I did do all this with the eventual aim to get it back into the Python mainline. The work that's going to be required on Linux and BSD. So that basically boils down to there's a couple of facilities that Windows provides that's really useful. So the way that they provide memory management. So their ability to allocate individual heaps, and then rather than calling malloc, what you would actually do is once you've got this heap created, to actually allocate memory through that particular heap. So a lot of it is just going to be providing similar sort of support or functionality on Linux or BSD. There's a whole bunch. One of the key reasons I chose Windows was because it really does provide such good scaffolding for writing these high performance parallel oriented. Windows has had threads from day one, whereas on Unix there was always this notion of the process and the process abstraction, and threads were really any kind of, I don't want to say bolted on as an afterthought, but they weren't really a key part of the design. So, you could see that in a lot of vendors where they struggled to get good threading implementations over the sort of the 90s and the 2000s. I think Linux only got threading support in, I can't remember the version, but it was, it was work that was like funded for by IBM, because it wasn't, it's not an easy problem to solve on the Unix paradigm way of doing I/O and process.
How does PyParallel get around the limitations of the global interpreter lock without removing it?
So that's a great question. So that phrasing is definitely one that I've used, and I keep reiterating it. A lot of the complaints that people make about Python and the GIL, they're all centered around, okay, like, how do we remove the GIL? Removing the GIL, so the GIL actually is great. It serves a very useful purpose. It ensures that at any one time the interpreter only has one thread of execution running within it. The way that I addressed the problem was, well, that's what problem we're actually trying to solve, and that is the problem of I want to optimally use my underlying hardware. So the PyParallel solution is to leave the GIL alone. It has very well known semantics. It's relied upon. There's you've got all this C API compatibility that you're going to need to maintain, and the ability to be able to pause all parallel threads and single step through something and ensure that nothing's releasing and acquiring a GIL is quite useful. So the PyParallel approach is to simply essentially sidestep it, and it's a great sort of turnout that actually worked. Like I could basically augment all of the thread sets and parts of the interpreter, including GIL acquisition and GIL release, and essentially do that. So that was a very nice surprise that came out of all of this work.
And is there any special syntax required to take advantage of the parallelism offered by PyParallel? And how does that interact with the threading module in the standard library?
Right. So one of the key design decisions that I made up front was that I wasn't going to support free threading. So being able to take an existing program that was written using the threading.thread, classes or subclasses, I had no intention of suddenly being able to magically make that run on all of your cores. There's a couple of reasons for that. The key one is that threads in Python have never facilitated, parallel computation. They've always been a means to essentially achieve concurrency. So you would, if you need to do a blocking call, so connect to a database or something like that, you could actually palm it off to a separate thread, and then, they weren't a great way to achieve a lot of things, especially under a high performance way, but it got the job done, and it's a very useful purpose. There's no code out there that was written that would suddenly be able to leverage the fact that it was now running in parallel. That's a really a new paradigm. So I focused on, okay, I set basically the bar to say, look, okay, in order to use these new parallel facilities, you're going to have to use the module that we provide. And I essentially centered around this notion of, you would define these completion-oriented protocols. So, and this is where there's a lot of overlap, and, commonality between PyParallel and things like Async IO and Twisted. So Twisted in particular was one of the things I most liked about it was its notion of completion-oriented protocols. So you would define these classes that were essentially, you'd define methods like connection made and data received and connection dropped and that sort of thing. And you would implement, how you wanted your program to behave when the protocol acts the way that it does. And then Twisted was responsible for calling you when that happened. So PyParallel leverages the exact same concept. So it's a very much, don't call us, we'll call you type paradigm. And that's really the key piece. Once you're using these new parallel modules, you can essentially have Python call back into your code in these parallel threads, and you don't have to create any thread pools. You don't have to do any of the stuff that's always made threaded programming hard, which is, and again, another key thing that I wanted to address, because I think a lot of people get threads are really just a vessel for achieving that, for allowing a process to execute something before it needs to wait on some file IO or wait on some network IO. So threads are really just a mechanisms, and I wanted to draw focus away from threads themselves and actually focus on, structure your program so that the work can live independently to the worker. So the worker being the thread and the work being processing of an incoming request. There's no real reason why that can't be done in parallel. Or just assume that everything's going to be in parallel until you need to serialize it. So it's an inversion of the way that we've approached programming today, where it's, everything is sequential, and then you attempt to try and farm out in parallel means where possible.
And so how does that particular paradigm or pattern, how is it related to the idea of functional programming, of having immutable objects and immutable processes without side effects?
Yeah, very similar. I mean, there's a lot of overlap with a lot of the concepts that you see in both functional programming, both the languages like Rust and Go, and it all really comes down to object ownership and object lifetime. When can you safely deallocate an object, and how do you prevent races to set objects? So the functional paradigm, what became very apparent is just to use the HTTP processing request. So when a web server gets in a request, of all of the objects that are allocated to process that request, none of them are actually required, and it's not overly true, obviously, but none of them are actually required once that request has been sent back or once that response has been sent back to the user. So PyParallel leverages that and essentially kind of, I wouldn't say forces you to write in a functional way, but it allows you to structure your program with similar sort of constructs.
So in the abstract for the PyParallel paper, you cite a simple rule: don't persist parallel objects. How easy is this to do with currently available concurrency paradigms and APIs? And would it make sense to add such support?
So that's a really good question. That rule was motivated by a couple of bits of advice that Guido gave me. So essentially, he's always asked, what are my constraints? What are my restrictions? So it became very apparent that the ease for which you can convey the new mental model that's required for this to take off and to not be like an absolute disaster for most people to adopt, the simpler I could get that, the better. So in essentially like sitting down and writing that documentation that I did recently, the thing that came out about that I could tie this down to this single rule of just don't persist parallel objects. And it turns out that when writing programs that leverage these parallel facilities, that's actually not that hard to do. It's actually pretty, I've written two semi-real life examples of an instantaneous Wikipedia search server that essentially basically has the entire Python process serving all of Wikipedia in parallel, and also an implementation of one of these, the Tech Empower frameworks benchmark suite. So none of the issues that I had getting those working had to do with me accidentally persisting parallel objects. A lot of it had to do with finding places where code that I was calling were persisting parallel objects. And really it boiled down to, if you've got some library that is, just say, for example, like a regular expression, the first time it comes across a particular pattern, it'll compile it, and then it saves that in a dict so that it can be quickly called back. So that concept is what I'm referring to when you're saying you can't persist parallel objects. And it sort of ties down to the way that the memory is currently allocated. But it's really more, the rule will outlive the current reasons for the rule, which are more implementation based. But I think, as soon as you get into anything other than a rule like that, you start having to deal with, who owns what's the object ownership, how do you do safety allocation, and that sort of thing. So the fact that I've centered on this rule, I think time will tell. Either you will be able to write useful programs with PyParallel or you won't. So I'm hoping that that plays out. That's something that we'll be seeing.
So for instance, how would one be sure to follow this rule when using Twisted or Async IO?
So that's so the other thing that clicked recently in the past couple of weeks is that PyParallel and Async IO are actually complementary, and Async IO and concurrent futures and all those sorts of things. So I haven't actually changed anything in Python that prevents that single-threaded event model. So the way that I would actually envision the two working together would be, so Async IO could essentially be used to drive PyParallel. So, for example, if you want to process a directory and all of the contents within it, you could actually wire up Async IO where you've got this main thread, you've got this ability to, mutate global state and that sort of thing. What that Async IO thing does is basically break a request down into, well, I've got 8 cores. I can actually dispatch this in 8 parts, and that's picked up by PyParallel. It's all within the same process. It's just a quick, copy from one buffer to another, basically. So I actually see the two living together in a sort of symbiotic relationship. The original intent was to, again, have PyParallel basically be Async IO, but I think that was unrealistic. Now that I have spent some time working with both, it's clear that they could actually really, when paired together, you could get some really cool new paradigms. And look at things like games. I mean, there's the single-threaded paradigm of one main event loop. That's quite powerful, and it's something that's existed for as many years as we have been programming, and it's something that probably will continue to exist. There's typically what you would do is start off with that. It's much more easier to reason about your program's logic in that state. And then there's going to be opportunities to, this particular piece of work is, needs to be done against a chunk of data. That data can be chunked into, 8 different pieces. Those can be executed in parallel. So that's kind of how I see all of that tying together down the track.
Yeah, it seems like your approach of having more of a functional paradigm for handling the parallel processes, it seems that will greatly simplify a lot of the trouble that has historically been associated with threaded programming of trying to figure out what order things are being returned in and how that mutates the global state of the program. And by not persisting anything in those parallel threads, you can remove a lot of that contention and the need for semaphores and mutexes and things like that.
Yeah, I didn't write a single mutex in all of PyParallel. I rely on the operating system to manage the scheduling of callbacks and that sort of thing, and it actually works really well. It's the old ways, sort of the Java style of locks against anything, concurrent hash maps and all that sort of thing. That's just none of that was necessary. It was strange. It was a change, because I did all of that sort of type of stuff, back in the 2000s, and it was nice not to have to deal with threads and locks and stuff directly. There's a bit of, I didn't write a mute. I did use a couple of the new Windows slim read-write locks. So there is some locking in some little parts, but it's in a very minimal case, and it's not something that I expose to the Python user. It just happens when it needs to behind the scenes.
So are there any operations that are not supported in parallel threads, or anything that a user needs to be aware of when they're trying to create a program that takes advantage of those parallel processes?
Right. So, I mean, other than obviously so you couldn't have like a dict in the main thread and then be able to just assign to that from parallel threads. That's I actually think so. It either crashes or I put some code into it's actually pretty easy to detect when that's happening. And raise an exception so that the parallel code can actually get that exception and handle it. The other restrictions at the moment are that you are disabled importing from parallel context, so you can't import a module, which is, that's a reasonable restriction. That is not a restriction that I have been butting my head against. So it kind of makes sense to do what you're importing in the main thread. The other restriction, I think I disabled tracing and per sort of thread stepping through at the CPython. That's a really specific change. I haven't done anything to support debugging of these parallel threads. That's going to require a bit more attention. So how do you actually... I did add preliminary support such that one of these parallel threads can actually acquire the GIL and become the main thread, but that would be used only in debugging. There's actually a way to efficiently synchronously call back into the main thread, which should be used. But for debugging reasons, it actually could be quite useful to have these parallel threads that if you're debugging code that works fine in the main thread but isn't working in the parallel thread, to actually provide a way to provide an option for debugging that. So other than that, it's you can't use any code that violates the restrictions of the don't persist parallel objects. So that's really the main takeaway. The other restrictions are just very small and very unlikely to be run into.
So going back to your point about debugging, it seems like some of the projects that have been coming up recently that enable remote debuggers might be a good place to start with pursuing that, in terms of being able to, as you hit an exception in one of the parallel threads, just have it stop, enter the debugger, and then I know that in Celery it will print out a port that you can then telnet to and step through the PDB at that point.
Yep, there's definitely a lot of opportunity to explore those sort of things.
So what drove the decision to fork Python 3.5 as opposed to the 2.x series?
So it was 3.3, but the tag was 3.3.5. I didn't actually... So that was... as much as I would like to say it was a calculated decision, I literally just started hacking on CPython on whatever the state of the repository was. So I think I had I was a core Python committer, so I was working on Python, I think what turned out to be 3.4 at the time, but it was essentially a checkout of the default, the master branch of Python source tree. So that happened to be Python 3.3 at the time. It wasn't really, doing it on 2 wasn't ever really something in my mind. I think at the time, again, I was motivated to try and essentially race Guido, so to try and get something on the plate where it could be considered next to this, the async IO and the yield from syntax and that sort of stuff. So there just wasn't any real viability of doing that in 2. And again, I wanted to support Python and support Python 3. If Python, ironically, if Python 4, if PyParallel ever does come into the mainline, increases Python 3's adoption, because PyParallel is going to track Python 3 as it goes, through its the next few versions. Hey, that's all better for Python, really.
And so, tying into that, in the documentation, you mentioned that the long-term goal for PyParallel is to merge it back into Python mainline. It says possibly within 5 years, and I'm wondering if anything has changed with that goal or the timeline, and what milestones do you need to hit before that becomes a realistic possibility?
Yeah, so the thing that's never going to happen is a big bang merge. So there's never going to be a point where I sort of email Guido and be like, all right, here it is, it's ready, I've finished all the patches, apply. It's really going to need to, and just because of this is the first time where we've been able to have Python code run in parallel threads. And it is experimental, it is proof of concept. We don't know, we're not Microsoft or Apple, we don't have the ability to figure out all the problems ahead of time. We kind of need to leverage the open source nature and leverage the community participation. So I really want PyParallel to live separately and independently to the main Python tree, because it's also a quality thing as well. People have come to rely on Python. It powers millions of websites and businesses, and is the language of choice for so many developers. So that would be a huge breach in our in the community's trust of us if we start just putting in PyParallel changes that crash or start to reduce that level of quality. That being said, the PyParallel does need to track. The way that I envision it playing out is actually tracking. So, Python 3.5 is due to be tagged really soon. I think we're in the second release candidate. The idea that I have in mind is once that's tagged, I will essentially attempt to rebase PyParallel against that. It's going to be a bit fiddly because there were a lot of changes to between 3.3 when I made it to where it is now, especially with all the memory allocators and that sort of thing, which is one of the areas where I do all the interception. But if there's sufficient interest, I want to use that opportunity to try and get it working again, get the build working again, just with these new primitives in place on Linux and OS X, so that we can actually build it. And from there, we've got the ability to, people can start implementing the platform specific stuff that's going to be required in order to achieve this. So I really do envision it tracking the state of the CPython repository over the next few years, and then depending on, what the level of change is. I think Python 4 is realistic. There's no, that's never been, there's no sort of like release schedule for Python 4 at the moment. But because of the nature of the change, I think it would make sense. But I actually do see PyParallel going in lockstep with the core Python development over the next few years until we can say, okay, look, we've ironed out all the bugs. It's matured to a point where, we're happy basing this off. So it's, the other key thing is that, we're attempting to solve, how is Python going to be able to continue to flourish in the next 25 years without undoing all of the benefit and progress we've made in the past 25. So that means, ensuring that there's as much compatibility with the sources there, so that people don't have to continually rewrite their modules and rewrite all of this Python code that they've been using. So that's it'll be interesting. It's obviously going to need some involvement from the community on the Linux and OS X sides. I think once people see the advantages of the implementation that it'll scratch, and someone will want to scratch an itch and get involved.
So what are some particular problem areas that you're looking for help with, or particular areas of expertise that you would like people to bring to the table in terms of moving the project forward?
Yeah, so it's an interesting one. So the guild problem is, it's constantly discussed on the Python ideas list and Python dev list. I think the biggest issue that Python's going to have, it was designed in 1990, I think. Guido started making his first commits and released in 1993, I think. It's, there aren't really many other projects out there with that age where they are trying to attempt to do something that is kind of radical. So there's a question of do open source languages need to rock the boat and try and come up with these, aggressive ways of staying relevant as, hardware matures and as, technology evolves. So that's more of an open-ended problem that it's going to be interesting to see, to see what the reception is like to PyParallel. So the GIL isn't removed, but the limitations of the GIL are removed, and it essentially allows you to effectively exploit your underlying hardware. So but it's a new concept. Everything that I had to come up with to solve it, I had to essentially invent. So I can't really tie it to a known paper of we implemented this particular technique to solve X, Y, Z. It's all kind of just fitted together as it had come along. So it's going to take time for people to just understand how it works and what are some of the limitations on it. Maybe it doesn't end up being the way that Python progresses. It could quite easily just live as its own particular problem. I think that's the biggest area, just to get people's awareness of the project and to be willing to play around with, especially if you've got Linux and Unix skills, when we do start the rebasing against 3.5 to start getting involved and seeing if we can get parity between the Linux and POSIX stuff and the current Windows implementation.
For anybody who's interested in checking out the source code for this or checking out any issues that might be filed against it, where can they find that?
So github.com/PyParallel/PyParallel. So the website PyParallel.org also links to the GitHub page as well. So that's a good starting point.
And for people who do dig into the repository, are there any particular open issues that you have on your high priority list, or any?
So there's one issue so I only just recently migrated it to GitHub. There's definitely some work that I need to do in order to structure the things that need to be done in such a way that people can start contributing. So I anticipate that taking place over the next couple of months. There's one issue in there at the moment where someone's asked whether or not it supports Linux. So I said not yet, and patch is welcome. But there's no list of work items yet, but that's something that I'm looking to work on going forward.
So before we move into the picks, is there anything else that you wanted to bring up or mention to our audience?
No, I think there's definitely a lot more to talk about. So I definitely look forward to, if you'll have me back on the show, we can jump into some other details and continue discussing some of the ideas and topics that we're dealing with here.
Yeah, definitely. We would love to have you back on the show to dig a little further into this. So we'll work on getting that scheduled, and anybody who's listening, keep an eye out for that, and we'll continue this conversation. So for picks, I will go ahead and get us started. And my first pick today is a project called Test Infra, and it is an infrastructure testing library that is a plugin for PyTest. So it can be used as an alternative to the server spec project, which is written in Ruby. So it gives everybody who is doing systems engineering using Python-based, or actually any language-based configuration management tool set, it lets you use Python as your language for implementing those tests. So it's still kind of in the early stages, it looks like, but it seems that it's got a lot of really good potential and a lot of good basis for working forward with. And my next pick is a new podcast I started listening to recently called Software Engineering Daily. And the host has weeks that have a particular theme. And so the ones I'm listening through recently, he had a big data week where he interviewed people in the big data community about various projects such as Storm and Kafka. And the episodes I'm listening through right now are all around Bitcoin and the blockchain. So really well done show. Definitely worth checking out.
Excellent. Thanks. First of all, you scooped one of my picks because that Software Engineering Daily podcast is phenomenal. I've been really, really enjoying it. It really, runs the gamut from talking to some really big luminaries in the field, Schneier and all kinds of other great folks, to dealing with projects that I just haven't heard of, but really, wanted to know about. It's great stuff. And it kind of amazes me that he can put that on daily. I mean, it's a lot of work to do this weekly. I can't imagine cranking out a new podcast every day. That said, my picks are, my first pick is the Hello Web App Intermediate Concepts Kickstarter by Tracy Osborne. The Hello Web App book that she wrote initially is excellent. I'm a non-front end, back end infrastructure kind of guy, and web programming has never really made sense to me. And this is one of the first books that I've ever read that actually explained how to design a web app in really accessible terms. I really like it. I'm looking forward to the intermediate one. And everyone should go back that Kickstarter. My second pick is a beer. It's been a few weeks since I've picked a beer, and I encountered one yesterday that I really liked. It is called Rainbow Dome, oddly enough, from Grimm Brewing again. It's a really interesting beer. It's a sour, but it's got some really interesting flavors going on. It's, once again, sort of almost like luminescent yellow. Grimm seems to have a penchant for brewing beers that look really novel in the glass. So there's that. And my third and last pick, I will pick the PBS Idea Channel podcast. It's a great, a YouTube channel rather, excuse me. It's a great show. Every show he goes through some concept, whether it's something from current events or whatever. It's brilliantly produced with all sorts of little great video clips, and it's just incredibly intelligent and definitely worth watching. And that's it. Trent, what kind of picks do you have for us?
I have one pick, and it is a book called Showstopper, and it is by an author, G. Pascal Zachary. And it's the tagline on the book is "The Breakneck Race to Create Windows NT and the Next Generation at Microsoft." So this book was written in 1994, and I bought it recently. I bought it, I think, last year, and only ended up reading it sort of over the Christmas break. But it was a fascinating account of the development of the NT kernel, which is essentially what all modern Windows machines are now based upon. So it tracks the development project from David Cutler, who was the main architect on Windows NT. So his heritage came from, he came from digital, and he had a background in VMS, and it was in the late 80s he got a call basically from Bill Gates that had heard of his prominence, heard he was looking potentially to leave digital, and basically got free rein to build the next generation of operating system at Microsoft. So it was actually it's strange because I didn't actually know that connection until much later. And I know that my initial interaction with Windows, especially when as a teenager, it was the only thing that I really remembered about Windows 3.1 and Windows 95 and stuff was how often it like lost my homework and how often it would crash. That's, that stays in your mind. And it wasn't until I got into the enterprise where actually, there was a Windows 2000, which was obviously where the NT kernel came in, a Windows 2000 machine and SQL Server 2000, and I'm like, oh, maybe it's bizarre. The Microsoft I always had this really negative opinion towards, and that really just started the gradual change into interest within Windows and all of these primitives that I use within PyParallel, they can all be traced back to the sort of the fundamental design decisions that go back as far as VMS. So, and VMS was you couldn't get anything more different to Windows than VMS. This was like a system that was designed to reliably and safely run, business problems in the the late 70s and 80s and that sort of thing. So this book in particular, it's just fascinated me reading it because it gave a really close account of how Windows NT was developed from sort of the late 80s to its release in 1993. So I've got like 30, 40 little tabs poking out of it of where I found interesting little tidbits and comments and stuff. And it's interesting. I'm buying a lot older books now as I get older, which is strange. I bought a VMS book, which was published in like 1980, like the late 80s, I think. So it's interesting to see that transition as I guess, continue work as a software developer. The average age of the books of like when they were first published is actually getting older as well.
It's definitely a known thing that the longer you work in our industry, the more you realize that what's new is old, really, when you peel back the covers.
Definitely.
All right. Well, we really appreciate you coming onto the show to talk to us about PyParallel and all the interesting work that you've done on it. And for anybody who wants to keep in touch with you and follow what you're up to, what would be the best way for them to do that?
Yeah, sure. Visit GitHub/PyParallel, and favorite or star that. I can be reached. Actually, PyParallel on Twitter as well is a good way to get in touch. I can be reached on Twitter at Trent Nelson.
Great.
Good talking to you guys.
Have a good night.